Okay, so 129. So we're going to do what they call a linear regression. So when you so a linear regression, linear means straight. We know that, and of course, though our graph looks straight, didn't it? If we look at our graph, we did our scatter plot. It looks pretty straight to me. Okay, that's the linear part, and the regression is what the calculator does. It actually takes a look at all of the points, and it does a regression model in its own little program, and it averages the distances between all the points and finds the best line. Okay. We don't do that. We'll let the calculator do that, okay? So steps. First of all, we've got to go to stats. So let me get my calculator out. Okay, I'm going to go on, quit, clear, clear, clear. So I'm going to go to stat, okay? Go to stat. Then edit, because I need to add, change, or something. So I'm going to go to edit. Okay, enter. If you have numbers in your calculator already. Anybody already have numbers in the calculator? So you want to get rid of them. So you go up arrow, so you highlight your list. See how your list is highlighted? So go up arrow and highlight your list. Then push clear and down arrow. Push clear and down arrow and clear your list. Okay, so if I push clear, down arrow, clears my list. Anybody? Okay. So here we go. I'm going to show it one more time. Nice job. Okay, so you're going to just go to, let's see, I'll make sure you guys can see this. There we go. So I go over, go and highlight my list, right? Push clear, down arrow, okay? And then your list is cleared. So you have to clear your old data. You can't type over your old data. You got to get rid of it so we can put new numbers in, okay? Thumbs up. Everybody there? Yeah. Okay, good. Now let's just enter our data, okay? So I will put, clear old data, right? And then let's just put numbers in. So now enter data, okay? And you've got list 1, which will be my X values. And I've got list 2, which are going to be my Y values. Okay, so I'm just going to do that. So I go back. I'll let you guys see them. They're all right here. So you don't have to flip your page. There's all our data points right there. So go 4, enter, 7, 10, 15, 18, 24, 27, 30, okay? And then I'm going to go ahead and enter in the corresponding Y values into list 2, 1.5, 2.75, 3.8, 5.5, 6.6, 8.25, 8.6, and 9.1, okay? And I'll let you get caught up, and then I'll give you the next steps, okay? Okay, now, we're going to go back to stat. Okay, you're going to go back to stat. So go back to stat, hit the stat button. And this time we want to calculate an answer, okay? We need an answer. So we're going to go over to calculate. So over to calc. So we're going to go to calc. And then we've got all these choices, and we will look at some of these others as the semester progresses. But what we want is the linear one, right? Number 4, do you guys see lin reg? So we're going to go down to number 4, which is the lin reg, which stands for the linear. So that's my lin reg ax plus b, right? Number 4. Number 4, there we go. Enter. And now we did, these are good calculus because we did put our x values in list 1, right? It's just checking. List 1. List 2 is my y values, right? So I'm going to go all the way down to calculate because I want to calculate my answer, okay? So I hit calculate, okay? And there you go, okay? So here's my equation. I'm going to get, as an answer, y equals a 0.296x plus a 0.765, right? There's my equation. And again, I'm going to rewrite it as t of n, because it really has to do with time and number of people, right? Yeah. Interesting. You guys get, anybody else get a different answer than me? No. Okay, check your check your data again. Go back into stat. You might put something differently than we did. Yeah, just check your numbers, okay? Because you might have put something different, okay? Anyway, so T of n, 0.296 n plus 0.765, okay? How close was I? I wasn't too far off. 4/11 is. Yeah, I was pretty close. I mean, mine wasn't bad, but the calculators is always going to be better. Does that make sense? It's always going to be better. Now, is this a good fit? Well, I think it's a good fit, okay? But here's the deal. In statistics, especially in these days when all these new medicines are coming out and all these new studies, you have to prove your statistics. You have to say, hey, it's good. And they want to know this thing called the correlation coefficient, okay? The closer your data is to what 100% of my points fit on the line, the better for you. Let's say you're trying to get a $5 million grant from the government to produce new medicine, right? If you show all your data, they're going to say, well, show us if it's good data or not. You have to show the statistics behind it. So we're going to find this thing called a correlation coefficient R. Now, if you already got it on your calculator, anybody have an R or an R squared pop up? Okay. If you didn't, here's how you get it. So to get it, we're going to go into our catalog. And our catalog is in blue. So we're going to go to second, and it's down by the 0, catalog, okay? And if you run through this and turn it on and use the same calculator tomorrow, it'll still be on, okay? So I go to catalog, and I'm looking for a diagnosis. And I want to turn it on if it's not on. So I'm going to go all the way down. I'm looking for diagnosis. Am I going too fast? So I went to catalog. And I'm looking for this thing called diagnosis. So I go all the way down to this thing called diagnosis. We want it on. Diagnosis on. So you want to turn it on. So there it is. You just want to turn it on. Okay, make sure everybody turns it on. On. I'm going to push enter. Yeah, okay, done. So you got to hit it again twice so it says done. So now what you've done is you've enabled your diagnosis part of your calculator. When you do this again, you'll get an R value. Okay, so I'm going to do it again. But I'll wait for you. Everybody got it on? Anybody? I'm waiting on anybody? Okay, so let's do it again. Let's go back to stat. Calculate my linear regression, right? I'm going to go down to calculate. Boom. Now there it is. Now R of 0.99 is like saying 99% of my data fits. That's good, isn't it? Wouldn't you think so? Yes, Daisy.
What about the R to the 2?
So R squared, we don't need the R squared. We just need the R. Great question. So my R is about a 0.991. That means about 99.1% accuracy. I like that. That's a good correlation coefficient, all right? Now, real quickly, something that would not. So this tells me how good it is. So if I have a negative R, I'm going to give you 2 more examples, okay? First example, positive correlation. The more people we have do the wave, the more time it goes. It's a positive correlation, right? As we add people, the time increases. Okay? Here's a negative correlation. Negative correlation, all right? Snowpack in the mountains and the summer months. Snowpack decreases, right, as the summer month time progresses, right? More days in the summer. So it would be a negative correlation. Does that make sense? Snowpack decreases as the days of the summer increases. So it'd be a graph that would look like, it'd be going down, wouldn't it? It'd be a negative correlation, okay? Here is a no correlation at all, okay? Cole's going to love this one. Xavier's going to love this one. Height and IQ. Okay? Height and IQ. The taller you are, the less IQ you have, right? No. There's absolutely no correlation. You agree? There's no correlation between how smart you are and how tall you guys, right? And so if we were to measure people's IQs and their height, it would look like a shotgun blast. Does that make sense? It would look something like, and you don't have to draw this down, but here we got IQ and we got height. Realistically, it should look something like this, right? Do you see any kind of correlation? You do?
It looks like a star.
Yeah, I mean, there's no correlation. You couldn't draw a line in there at all, okay? This would be an R value of 0, okay? Snowpack and months would look something like this. This is time, and this is going to be snowpack.
But is it progression because the summer when it get warmer? So it would be more
So, oh, that's good. I did time instead of temperature, and that would be a different graph, wouldn't it? Good job. Yeah. Okay, that's all I have. Let me go ahead and stop recording it. And